To simplify a trig expression that looks like this, I just have to realize that this is the reverse of those sum and difference sine and cosine formulas we've looked at in class. And so what I want to do first is figure out specifically, is this a sine or cosine? And what I do is I take a look at the first two, I guess, pieces, if you want to call them that. Since they're different, this was the pattern of the sine function, the sum or difference of sines. So I will begin this problem with a sine. If they were the same thing, they were cosine. Now that's what I did. Someone in class realized, hey, it's just whatever's first. So since sine came first, it's a sine function. I could be really tricky and like swap where those two were written. I don't think I would do that to you, but just keep that in mind. If the two terms are different, it's a sine. If they're the same thing, it's a cosine. So this is a sine problem. So I'm going to have this written as the sine of either two angles being added or subtracted. And again, looking back to how the pattern worked, when there was a subtraction sign here with sine, that sine, S-I-G-N, stayed the same. So this is still going to be a subtraction problem. Okay. From there, it's just a matter of plugging in our A and our B values. A and B are just the two angles that we have in order. So that's going to be angle A, which is 80, minus angle B, which is 20, and from there we see how easy these problems really are. So this becomes the sine of just 60 degrees, 80 minus 20 is 60, and since 60 is a special angle, I can just look that up in my trig ratio chart, and I see that that is the square root of 3 over 2. So while the original problem may have looked scary, they're really not that bad at all. Okay, and I'll show you one more example. In this case, again, I want to start with, is it a sine or a sum of sine or sum of cosines problem? Since these first two pieces are the same thing, they're both cosine, that's our evidence that we're dealing with the cosine sum or difference problem. So I'll do cosine in parentheses. And again, some people realize, hey, if it starts with cosine, it's cosine. So whatever. With the cosine pattern, our signs were the opposite in the middle, though. So if there was a plus sign right there, there was a subtraction sign in my problem down here, or in my expression down here. So in our previous videos, we had converted radians into degrees. I can do that again, although I don't really need to. This time you'll watch and see how easy this is. Again, A and B are just your angles in order. So this becomes then 11 pi over 4 for angle A, or I'm sorry, over 8. And then angle B was 7 pi over 8. And so since we have a common denominator, I can go ahead and just subtract those numerators right away. 11 pi minus 7 pi is just 4 pi, and then your denominator stays the same over 8. Well, 4 pi over 8 is the same thing as just pi over 2. And pi over 2 is one of our special angles. It's 90 degrees, it's a quadrantal angle, and so again, looking that up in our trig ratio chart, I see that the cosine of 90, or the cosine of pi over 2, is just 0. So that is what this expression would simplify to.